Hi everyone, I'm Cheryl. This problem involves higher order differentiation of a vector valued function along with some other vector operations such as the dot product and the cross product. Okay, we're going to begin by taking a look at my vector valued function. I have 1/2 t squared times I minus tj plus 1/6 t cubed k. And my first problem is to find the derivative of that vector valued function. So I'm just going to take the derivative of each of the components. So I have 1/2 times 2t times vector I minus the derivative of t is just 1 times vector j plus 1/6 times 3t squared times my vector k, which simplifies to t times vector I minus j plus t squared divided by 2 times vector k. That's the first derivative. Now I'm going to take the second derivative, which means I need to take the derivative of the derivative. So the derivative of t with respect to t is just 1, so that'll be vector I. The component here is a -1, whose derivative is 0. So I have 0 times vector j. And here I'll have 1/2 times the derivative of t squared, which is 2t, times my vector k, which reduces to vector I minus 0j, so I can leave that out, and a plus tk. Okay, that's my second derivative. Now I'm going to find the dot product of my first derivative and my second derivative. So let me copy those down here for just a minute. My first derivative, remember, was ti minus j plus t squared over 2 times vector k. And I'm going to take the dot product of that with I, and I'm going to put in the 0j and plus tk. Now, if you remember, when you take a dot product, you multiply the components of your I term and you add that to the product of the components of your j term, and you add that to the product of your components of your k term. So I'm going to have t times 1 plus a -1 times 0 plus t squared over 2 times t. So my dot product is t plus 0 plus t cubed all over 2. Okay, the last part. We're going to do a cross product this time. So to set up my cross product, remember, I'm going to use a determinant form with vectors I, j, and k in my first row, and the components of r prime make up my second row. So that will be a t, a -1, and a t squared over 2. My third row will be the components of the second derivative, which will be a 1, 0, and t. Okay, so to evaluate this determinant, I'm going to start out with my vector I. I'm going to eliminate the column and the row with I in it, and I'm left with this little square determinant in here. So it's going to be -1, t squared divided by 2, 0, and t, that determinant times vector I. Then I'm going to subtract the determinant after I eliminate the row with j in it and the column with j in it. So that's going to look like t and t squared divided by 2 and 1 and t times my vector j. Then I'm going to add the determinant when I eliminate the row that has k in it and the column that has k in it. So that's going to be t minus 1, 1, and 0 times my vector k. Okay, now I'm ready to take the determinant of these smaller matrices. So the determinant here, if I cross this way, I will have a negative t, and then I'm going to subtract this product, which is going to be 0. And that's times vector I. For the second piece, again, I'll have t squared minus t squared over 2 times my vector j. And then for the last piece, I will have 0 minus a negative 1. And that's times my vector k. All right, so let's do some simplifying here. I'm going to end up with a minus t times my vector I minus the quantity. Well, actually, I can simplify this as well. This is t squared minus t squared over 2. So that can reduce to just t squared over 2 times my vector j. And then 0 minus a negative 1, that's a positive 1. So I just end up with k. And there's my cross product. I hope that was helpful. Thanks.